Hi everyone, welcome to this video. So here we are gonna solve some thermodynamics questions, a bunch of questions which will be from your module, but still you can see the question on the board. Don't go for the question number because it might be 14, but actually this is the first question. So it is 14 from your module, from your JEE module. So let's start, let's dive in. So first question says 10 liters of a monoatomic ideal gas at 0 degree centigrade and 10 atmosphere pressure is suddenly released to 1 atmosphere pressure. So can we just list down all the things that is given? So first of all, 10 liter, that means volume 1. Initial volume is given, which is 10 liter, right? So it will be 10 liter. Initial temperature is also given, which is 0 degree centigrade. We know how to convert this to Kelvin. So this will be 273 Kelvin, right? Now initial pressure, it is given as 10 atmosphere again. Let's write the final things. So final volume, you have to find out. Final pressure is gas expands adiabatically against this constant pressure. Okay, so the pressure is constant here. Released to 1 atmosphere pressure. Sorry, it's not constant. P2 is 1 atmosphere. So initial pressure was 10 atmosphere and final pressure is 1 atmosphere. Now you have to also find out T2. Also, what is the process? So the process is adiabatic process. But can you see one more thing along with adiabatic word? You can see suddenly released. This word, suddenly released. What does that mean? Suddenly released. This means the process is adiabatic irreversible. Okay, adiabatic irreversible, and in that case we cannot use PV to the power gamma equals to K. We cannot use this thing. For adiabatic irreversible we cannot use this formula, right? So rather we can use something. चलो एक चीज बताओ, if this is adiabatic तो dq heat change क्या हो जाएगा? It will be 0. So from first law can I write W is equals to du? This will be from first law, right? Because first law क्या होती है? du equals to dq plus w, work done. So here dq equals to 0, so du will be equals to w. Now I'm going to the next page. So du equals to w, and for an adiabatic process du का formula क्या होती है? It is P2 V2 minus P1 V1 upon gamma minus 1. We all know gamma is Cp by Cv, right? Equals to W. W क्या होती है? Minus P external into V2 minus V1. This is for adiabatic irreversible process, right? We cannot use that PV to the power gamma equals to K. Now all these values are given, but gamma, what is gamma? So gamma for monoatomic gas, since the question says the gas is monoatomic gas, so obviously the gamma will be 1.67. We all know the gamma, the value of gamma for monoatomic gas is 1.67, right? Let me go back. So gamma will be 1.67. Now if you look at the questions, all the values are given. So P2, what is P2? It's 10 atmosphere, right? Into what is V2? That's what we have to find out. Minus P1. P2 will be 1 atmosphere, right? And P1 will be 10 atmosphere into V1 is also given, which is I guess 10 liter if you check it. Gamma is 1.67 minus 1 equals to P external. What is P external? That is nothing but the final pressure, and final pressure is 1 atmosphere. So this will be 1 into V2 minus V1, and this will be 10 minus 1. V2 is we have to find out. So obviously V2 minus 10. This will be your formula. So all the values are given. You can check out the question from the last slide. So if you just solve this the whole thing, so this will be V2 minus 100 equals to, this will be 10 minus V2 into 1.67 minus 1, it will be 0.67. So this will be your final formula. And if you just solve this, so you will get V2 equals to 64 liter. You can just solve this and you will get V2 equals to 64 liter. So we got V2 as 64 liter. Now you can check out the option, but also you have to find out T2. So we know for a diabetic process PV to the power gamma hoti hai, right, equals to constant. Now we have V1 10 liter, we have V2 64 liter, we have T1 that is our 273 Kelvin, and we have to find out T2. So obviously P के जगह we can write PV equals to nRT, you all know. So P के जगह मैं क्या लिख सकता हूँ, T by V. So if I just write T by V here, so it will be T into V to the power gamma minus 1 equals to K. This is the formula for a diabetic. Now T2 into V2 to the power gamma minus 1 equals to T1 into V1 to the power gamma minus 1. All the values are given. Gamma is also given, that is 1.67. So if you just compile all the values and plug in all the values in that particular formula, you will get T2, and T2 will be 174 Kelvin. So you got your V2, that is 64 liter, and you got your T2, that is 174 Kelvin. Let's go to the question once and see what is the correct option. So if I just go to the option question, so it says T, final temperature is 174 Kelvin and final volume is 64 liter. So obviously our answer will be option 1. Thank you for watching this video. Please stick for the next one.